Hello everyone. For this video, we'll be going through some questions for circular measure. For circular measure, you only have a few formulas that you need to remember from maths, and the other formulas all come from your basic knowledge in your normal maths, okay? So these are the two formulas that you have learned in maths: r theta to find the circumference or part of the circumference, okay? Or half r squared theta to find the area, or again half of the area of the sector. Okay, they have half AB sine C. This is to find the area of a triangle. A squared equals to B squared plus C squared minus 2BC cos A. This is your cosine rule, and also your SOHCAHTOA for your right angled triangles. All right, so these are the few formulas that you will need to use in this particular chapter here. Now let's look at some example questions together. The diagram shows a circle with center O and a radius r cm. The minor arc AB is such that angle AOB is theta radian. The area of the minor sector AOB is 48 square centimeters. Show that theta is equals to 96 over r squared. Now, so since we've been given the area here, okay, so I can say that half of r square theta is actually equals to 48. Okay, this is the formula, isn't it? When they say minor arc AB, they're talking about this, okay, this one here. And it is the minor sector. So forming the equation from here, what we needed to do is just to make it so that we can change this equation into this equation here. And then that would be by using algebra, bringing all the other values over, bringing half over, you're going to have 2 times 48. Therefore, it is 96 is equals to r squared theta. Bringing r squared to the right hand side is going to be divided by r squared. And then that will just be your answer straight away. Theta is equals to 96 over r squared. Then that's just basically you showing that you are done here. Okay. Next, given that the minor arc AB has a length of 12 cm, find the value of r and theta. So they're telling you that this minor arc, the length here from here to here is 12 cm. It's always good, guys, to label all the things that you've been given in your question onto your diagram. Okay, it's easier for you to visualize it that way. So what we're going to do is we are going to use the first formula over here. R theta is equals to 12. R theta is equals to 12. All right, and from here what we can say is that to find the value of r and theta, we actually need to use like somewhat of a simultaneous equation, making the theta the subject. In this case, theta is equals to 12 over r. Then from here, we can equate both of these equations here. 96 over r squared is equals to this 12 over r, because they are both equals to theta. You see, they are both equals to theta. Then again, once again, using algebra, solve it. You have 96 over 12 is equals to r squared over r. Then this will naturally cancel off. R, in this case, would equals to 96 over 12, 8. Since r equals to 8, to find theta, 8 theta is equals to 12. Theta is equals to 12 divided by 8, which is just 1.5. Okay, and from here we would have solved for r and theta. And in the next part of the question, using your values of r and theta, find the area of the shaded region. So they're asking us to find this region here. What we're going to need to do to find the area of the shaded region is, first we must find the area of the whole sector. The area of the whole sector, and we need to minus it with the area of the triangle there, using the two area formulas that we have here. Okay, so first, finding the area of the sector is going to be half r squared, which we know is 8, theta, which we know is 1.5. Okay, this is the area of the sector. Minus it off with the area of the triangle, which is, for the area of triangle is half AB, which is both the radius, AB, and then sine theta, which is again 1.5. Okay, so from here, just type everything into the calculator and make sure that your calculator is in your radian mode, okay? Because in this case, if you did not, then your answer will be completely wrong. So make sure your calculator is in radian mode. 0.5 times 8 squared times 1.5 minus 0.5 times 8 times sine 1.5. Okay, you should have gotten an answer of 16.1. Your answer for the first part should be 16.1. Okay. For your next question, in the diagram, AOB and DOC are sectors of a circle with center O. The angle AOB is x radian. The length of the arc AB is 40 as stated here, and the radius of OB is 16. Find the value of x. To find the value of x, what we're going to need to do is use this circumference formula here. R theta, R which is 16, theta which is unknown x, is actually equals to 40 as shown in the diagram here. Okay, so this is equals to 40, and x would therefore be 40 over 16, which is then 2.5 radian. Okay, so x is 2.5. Find the area of the sector A, O, and B. That means we're looking for the whole thing here. So that's very straightforward again. Half of r squared times theta, which is 2.5. This will simply give us 16. Then this is actually 320 square centimeters. Okay. Okay, moving on. Given that the area of the shaded region ABCD is 140 square centimeters, find the length of OC. So they're saying that the area of this shaded region here is 140 square centimeters. What you want to do is you want to find the length of O to C. Okay, you find the length of O to C. So what this simply means is, if I use the area of the enlarged sector, all right, of 320 square centimeters, I minus this shaded region here, minus 140. Okay, I'll be left with 180. So that's exactly how big this is. This area, the unshaded region, has an area of 180 square centimeters. And then from there, what we can do is we can use whatever variables that we already had. Half of r squared, which is the unknown right now that we're looking for, multiplied by the theta, which is still 2.5, okay, is equals to, wait, how much was it equal to? 180. 180. So from here, 180 divided by 2.5 times 2, square root this answer, you would have gotten that x is basically 180 multiplied by 2, because they bring the half up, okay, and then divide by 2.5, and then bring the square root over, you would have gotten x is equals to 12. And that's it. That's the length of OC. All right. Moving on to the next question. Find the perimeter of ABCD. Now, let's see the question here. The diagram shows a company logo, ABCD. The logo is part of a sector, OAB, of a circle, center O, radius 50, point C and D lie on OB, C and D lie on OB and OA, respectively. The length of AD and BC are equals, the length of AD and BC, AD and BC are equal, and A to D, AO is 7 to 10. All right, so this is 7, then if this whole thing is 10, that makes this region here 3. Okay, the angle AOB is 4 pi over 9 radian. So if that's the case here, if this is 7 to 3, that means in reality this is 35 cm, and this will be 15 cm. So the first question, they're asking us to find the perimeter of ABCD. ABCD would be adding this, and this. Okay, so we already know that this 2 here is 35 and 35. First, we're going to find the arc of the sector. So this is going to be using our circumference formula, R, which is a total of 50, multiplied by the theta, which is 4 pi over 9. This first part here is equals to 69.8. Okay, 69.8. This part here is 69.8, right? So there's 35, there's 35. Now, what we need to do is we need to find this length of DC here. If we were to just look at it as a triangle, we could see that this is 15, this is 15, and this has the angle of 4 pi over 9. So we are going to be using the cosine rule to find this side here. This side here will be A. According to the formula, A square is equals to B square plus C square, which is both 15 square plus 15 square, minus 2 times 15 cos 4 pi over 9. Okay, what you have is just type everything into the calculator from here. 15 plus 15, sorry, 15 square plus 15 square minus 2 times 15 times 15 times cos 4 pi over 9. Okay, square root this answer here. You're supposed to have gotten A is equals to 19.3. Okay, A is 19.3. Then the perimeter will just simply be 69.8 plus 19.3 plus 35 plus 35. So type everything into the calculator. Your total area should have been 159.1. Sorry, not area, this perimeter, cm. Okay, and then that should be it for this part of the question. Yep. Okay. In your next part, find the area of ABCD. So what we have here right now is, again, we have a full sector of the circle. Okay, and then we need to, in order to find the area of the shaded region, we need to minus it off with the area of the triangle here. Once again, we're using both these formulas here. Now, this should be pretty easy. First, we minus off. First, we find the area of the sector, half r, which was 50, square theta, which was 4 pi over 9. And we're going to minus it off with the area of the triangle, which is half times AB, which was 15 times 15, sine C. Again, same angle over 9. Okay. Type everything into the calculator. Square times 9 by 2. This part here should be 1745.3, and you're minusing it off with this part here. This part here is 100.8. So 1745.3 minus 110.8, you're supposed to get 1634.5 square centimeters. Okay, 1634.5 square centimeters. And yep, that will be it for this part here.